Alright, hi everyone. Today we're going to have a look at solving simultaneous equations by the method of substitution. Now, first of all, just a quick word on what solving simultaneous equations actually means. In Desmos here I've graphed the equations x plus y is equal to 8 and y is equal to 3x plus 4. Now, notice that those 2 points cross over each other here, so the coordinate there is x is equal to 1 and y is equal to 7. So when we solve simultaneous equations, we're looking at for that point where those two graphs of the lines will cross over one another. So x is equal to something, y is equal to something else. There's a whole range of reasons that might be of interest for us. We might be looking for the point at which your profit and loss for a company crosses over. It might be a break-even point. If you had say comparing the prices of two companies, it might be the cost at which they are worth the same amount of money or something like that. There's a lot of different reasons in this particular course for needing to do it. Now, yes, we've graphed it there. We can see what the crossover point is. So x equals 1, y is equal to 7. But we're not always going to be able to graph it. It's slow to do that as well. And it's also not the skill that's being assessed when you're asked to solve it by substitution. So that's what we're going to do here. So essentially what I'm going to show you right now is a method of finding out that coordinate there. So x is equal to 1 and y is equal to 7, but without graphing it and literally seeing where the crossover part is. Okay, I'm going to start out by writing both equations. So x plus y is equal to 8. I'm going to call that equation 1. That's quite important. And I'm going to write down my second equation, y is equal to 3x plus 4, and I'll call that equation 2. So this is where the substitution component comes in, because I'm going to literally take one of the equations and substitute it into the other one. And what I actually mean by that, if I zoom in a little bit here, make sure it's still on the screen. Okay, so I know that y is equal to 3x plus 4. So they're the same. That's the same, value. That equal sign means we've got the same thing on both sides. So what I'm going to do is take this 3x plus 4, put it into the first equation. So I'll have instead x is equal to, x plus 3x plus 4 is equal to 8. So it seems a little bit confusing, but because I've got the equal sign there, it means that they've got the same value, so I'm able to swap them around like that. But don't forget, that's because we're looking for this point just here, the point on the graph or for both graphs where both equations apply to it. So that's why we can swap them around in this way. Okay, so what I need to do now is tell the reader or the marker or whoever, which will be me in a lot of cases, I'm going to write down what I'm actually doing. So what I'm actually going to do here is say, well, I'm going to substitute equation 2 into equation 1. So it's important that I make it very clear what I'm doing, which is why we use these labels. So now I'm going to rewrite the first one. So x plus, and I'm going to use my substituted value for y, which is 3x plus 4 is equal to 8. Now the reason that we do this is because now in this new equation I've only got one unknown, one variable, so I'm able to solve it. So by chipping away at this one, 3x plus x is 4x, 4x plus 4 is equal to 8. That means 4x is equal to 4, and indeed x is equal to 1. Look, we have the exact value for x that we were expecting to find. So we found that x equals 1 from the crossing over point, the point where the linear graphs meet. So what I need to do now is find my y value. Now your labeling has to be quite similar for this one. You still have to make it clear what you're doing. So I'm going to say that I'm going to substitute x equals 1. So that's important for your follow-through working if you make a mistake here. I'm going to substitute that into, doesn't really matter which one, but I'll substitute that into 1 as well. Because for that one, if you've got your value for x, you can then solve it to find your value for y. So then equation number 1, x plus y is equal to 8. I'm pretty sure. Yeah, that's right. So now I've got 1 plus y is equal to 8. or y is equal to 7. Okay, now we've got the same thing again. We've got the y coordinate that we were aiming to find. We've got x is equal to 1, y is equal to 7. So that's showing you how you arrive at that answer in a substitution method type way. And then for your actual answer, I'm going to say therefore x equals 1 and y equals 7. So that's your final answer, actually stating what the coordinates are for that crossover point. Alrighty. Now if you'd like to hang around, we'll do another couple of questions, which I will now copy down. We'll start off with, I'll just get rid of my keyboard. We'll call this one example B. So we've got 2x minus 3y is equal to negative 8. I'm just going to call that equation 1 in advance. And y is equal to x plus 3. Okay, so this one is a little bit more advanced than the first question. The reason being that the value that we're going to substitute in, so we've got y is equal to x plus 3, but when we substitute that into equation 1, y is actually worth 3 lots of what we're going to substitute in there, and there's also a negative sign that threatens to throw us off as well. So this is a little bit more complicated, but it's not above our level of skill. What I'm going to do now is just keep working this on the right-hand side here, so I don't draw over my face. Okay, so my technique for this one is going to be to substitute number 2 into 1. Okay, so that's going to give me 2x minus 3 lots of my value that I'm substituting for y, which is x plus 3, minus 3 lots of x plus 3, and that's equal to negative 8. Okay, so now, same thing again, I'm going to... Oh, there's an email from me that I'll have to delete out later, I imagine. Okay, so, alright, so now we've got a equation with just the one variable, so we can start whittling it away and solve for that one variable. So I'm going to say 2x minus 3 lots of x minus 9, because it's 3 times x and, sorry, negative 3 times x and negative 3 multiplied by 3. It gives us negative 8. 2x minus 3x gives us negative x. Add 9 to both sides, so negative x is equal to 1. We'll make that a little bit neater. So if negative x is equal to 1, divide both sides by negative 1 to give me x is equal to negative 1. Cool. So that's coordinate number 1, so I'm halfway there. Know what I'm going to do, and it looks like substituting into equation 2 is going to be easier, so I'm going to do that. Substitute x equals negative 1 into equation 2. You could substitute it into equation 1 if you wanted, but when you're under time constraints in an exam, there's no point making life harder than what it needs to be. So you may as well save yourself every little second. Alright, so y is equal to negative 1 plus 3, which of course is 2. Answer, x is equal to negative 1, y is equal to 2. Don't forget that. The whole point of solving these simultaneous equations is to give us 2 points at which we, or the 2 coordinates at which the lines cross over. So that has to be your actual answer. Okay, we'll do one more. So we'll call this example C, because C comes after A and B. Let's say y is equal to negative 3x plus 2. Call that equation 1. And we'll go y is equal to 7x minus 8. We'll call that equation 2. Okay, so this one looks a little bit different. Again, this time what we'll do, because both equations are in the format of y equals mx plus c, we'd have to do it in a similar way to what we did before. We'd have to do a bit of rearranging, but there's actually no real need for that. What I'm going to do instead, I'm still going to substitute 2 into 1, But I'm going to take my 7x subtract 8, which is what y is equal to for this one. I'm going to put it right at the front there, so it's a little bit different in the way we structure it, but really it's exactly the same. So we're substituting 2 into 1, but we're going to have to put that new value for y on the left-hand side of the equal sign. So now 7x minus 8 is equal to negative 3x plus 2. We're still solving for the one variable, which is for x. The only difference this time is that we've got the variables on both sides of the equal sign. But that's fine, that's within our skill set. So adding 3x to both sides will give me 10x on the left-hand side. Adding negative 8 to both sides will give me, sorry, not adding negative 8, I apologize. Adding 8 to both sides will give me nothing on the left-hand side and 10 on the right-hand side. Then it's pretty simple. If 10x equals 10, then 1x has to be equal to 1. So that's my first coordinate. Second one, they're pretty much as easy as each other. I'll probably sub into 2. So sub x equals 1 into 2. So now a new equation, y is equal to 7x minus 8. So now y equals 7 times 1, which is 7. Take away 8, which is, of course, negative 1. And again, it's a simultaneous equations solving question. So we need to write down our solution. So x is equal to 1, y is equal to negative 1. And then chuck a big yellow highlight through there because that's the most satisfying part of finishing your maths problems. Okay, that's it for today. Thanks very much.